Good morning. I had a student mention the other day, and I actually had one or two students who are, I guess reasonably tied to the fact that they don't want to look at a pin joint as an unknown force and a known direction. And you see the book right there, so that point right there. In other words, you can look at a pin joint as being either an unknown magnitude of a known direction or it being a set of x and y components, with the x and the y components bound together by usually a tangent. Remember, the tangent of an angle is y over x. So if you are given something 26 foot long with a 10 foot a load given down 10 foot from the left side being A, right side being B, it being a simply supported inclined beam, I will tell you the most logical way to do that is going to be by assuming this is going to be, in most problems that are pin joints, by assuming a unknown magnitude of a known direction. However, you can go about doing it this way and doing the pure algebra, so I'm going to do that right now. What you have to realize here, if you break this up into components, right, you always show your components positive, but you're going to know that if you have 12 in the y, you're going to have a minus 5 in the x. So you know that if the reaction at x, so we'll call that reaction at b at in the x, you're going to know that the reaction at y in the x is equal to 12/5 of it. And so you write an equation that reaction at b in the x equals 5/12. And not only that, you know that it's going to be negative. And that's where I think the reaction of b and the y. So you have to understand that you're going to have both the sign and the ratio there. So I think that's where some people will tend to go somewhat badly on this, but let's see how this now works. Now you're going to write a sum of the moments about point A and make it equal to 0. With, of course, you're going to show a positive moment, as you always probably generally do for now, until you realize a positive moment just means compression in the top fibers, right-hand coordinate system. And so then you know that this direction here, that distance there is 10 and this distance is 24, and so you're going to see that is these are the moment arms of the components as opposed to the 26-foot moment arm of the pure contact force. And so we're going to go left to right across the system. We're going to write down force to 500 pounds times 10 feet. And then we're going to decide, is it positive or negative? Well, by the way, we're showing the force. And we are showing the force as causing a negative spin. And we're then going to say, because we're showing this, we're going to show these reactions always here as positive, right? You're going to tend to always show your reactions as positive even though you know they're negative. And so we're going to take next the reaction at B in the X, and that of course is going to have a moment arm. If you think about it, it's in the X direction, it's going to have a moment arm of 10, and it is also spinning in the negative direction. And then we're also going to finally take the reaction at B in the Y. In this case, it's times 24. And now that, as it's shown, is causing a positive. So you have one equation here in two unknowns. Now, the reality is now you have to bring in the other equation you have, which is this. The reaction at B in the X is equal to minus 5/12 of the reaction at B and the Y. So what you've done is, as opposed to just having this kind of one equation, one unknown, you now have to use these two equations and two unknowns and then solve them. Now, I will say for many students, you know, solving this can take as much time as laying out the problem. So I'm going to first do this here to set it up in the way that we know to use reverse row echelon format, and then I will actually solve it algebraically. And so you remember we do AX plus BY equals C as our formats. In this case, the X and the Y, right, are actually variable 1 or variable 2, and so we're going to set X equal to reaction at B and the X, and Y as the reaction at B and the Y. And so what we have is our formats here. We're going to go ahead and minus reaction at B and the X times 10 plus the reaction at B and the Y times 24 equals 5,000. Right, because we take this to the other side. And we'll do the other one in the same format. The reaction at B in the X plus 5/12 reaction at B in the Y equals 0. And so in these two right here, you have solved the equation. What I'm going to do right now here is stop and pause this, double check that on my calculator first, and then try to do it here with the calculator as it exists here in on the computer. So that became your two equations. You have to remember when you do your equation about something here that you have to remember that the sign is going to come in. The sign is going to come in when you do this. And usually you'll be doing it based on a direction. Remember that direction angle there, and that would have come in as well. So I'm going to go ahead and hit a pause here. Alright, I came up with numbers here of minus 73.964 and 177.515. That seems to be familiar from what we had done before, but let's go ahead and see if we can do this reverse row echelon matrix. At least we'll look what the matrix looks like. So the matrix looks like, I'm going to go ahead and do a little bit of erasing here so I don't have to move off the pen. I'm going to go ahead and erase out my structure here if I could. Alright, we can bring that back if we want. So remember that the format you have to use for reverse row echelon format, or for Cramer's rule, if you remember, is you have to get things in the format of AX plus BY plus yada yada equals something else, and you've got to have the requisite number of unknowns and equations. I'll just do that. C dx plus EY plus yada yada equals F, and then you write your matrix here, a 2 by 3 matrix, and you do the reverse row echelon format of that matrix. We have to remember now our numbers would be minus 10, 24, 5,000, and our number here would be 1, 5/12, and 0. And when you did that, you would get up a matrix that looked like this: 1, 0, minus 73.96, and 1, 0, 1, 177.52. And you know, of course, your check would have to be the reverse tangent of that, or the ratio of those being 5 to 12. Let's try it. 12 divided by 5, enter, times minus 73.96 gets you the 177.50, and then the reverse tangent, second reverse tangent of minus 73.96 divided by 177.52 gets you, of course, that 22.6 that we saw before. All right, so what you saw here is, remember, you don't want to stumble when you get to this point, nor spend a lot of time. You want to go ahead and get some tools, and of course you'll want to do it a couple ways anyway. Thanks for listening.